This video I want to talk to you some about alcohols and the reactions that they undergo. There's two main types of reactions of alcohols that we're going to talk about. One is eliminations and the other is oxidations. We'll get to the oxidations here in a couple of minutes. Elimination. We talked about one of the main reactions that alkenes do is having the alkene and adding something across that double bond. This is an example of an addition reaction. And it turns out eliminations are exactly the opposite of additions. So if you go from an addition reaction from an alkene to an alcohol, then in an alcohol, if you put this sulfuric acid in, the opposite reaction can happen. You can take this and go back to here. If the reaction this way was an addition, the reaction this way is going to be an elimination. And that's exactly what can happen here. The only difference with this is that you can possibly get more than one different product out. So let me show you how that works. The way this works is that the double bond has to form between the carbon bearing the OH and a carbon adjacent to it. Of course, adjacent means next to. So you need to ask yourselves, well, how many different adjacent carbons are there to the carbon with the OH? Well, if I put a star by each of these carbons represent adjacent carbons to the one with the OH. So there's 3 here. Now both of these are methyls, so those are the same. However, this guy, this is a CH2CH3, this is not the same as these. So therefore that means this carbon is different to these. And if we have 2 different sets of carbons, that means we can form 2 different products. If I call this carbon A with the OH, I could potentially form a double bond between carbon A and carbon 1, or carbon A and either of carbon 2s. So I'm going to draw the product out that we get if we form a double bond between carbon A and carbon 1. In fact, that ends up being this guy right here. So let me just draw that out. This gives us a double bond between carbon A and carbon 1. However, the other elimination product is what happens when we get the double bond going between carbon A and carbon 2. Whichever one of these you choose to do is kind of up to you. I'm going to show it on the carbon pointing up, on the CH3 pointing up, and so what I get here is, if that's carbon A, that's one of my carbon 2s. These are the 2 possible products that I could get. Now one of the other things that you'll want to talk about is which is the major product, which is formed the most, and which is the minor product. Well, you're talking about 2 alkenes, obviously the same functional group here, but one it turns out is more stable than the other. The one that's more stable you're going to see the most of. So let me go through a little bit about alkyne stability with you, and then we'll come back here in just a minute. So alkenes, I want to show you here. We've got several different alkenes here. Take a look at this one. We have the 2 carbons of the double bond, and what I'm going to do is I'm going to put a red circle around each of those. Alright? And actually I'm going to make one addition here. I'm going to put a methyl group here. I didn't have that before, that was an accident. Now, when we look at this alkene here, notice they're all alkenes. This one has 3 hydrogens coming around it, but it's got 1 alkyl group. Alkyl group is just a way of saying carbon group. There's 1 carbon group coming off here. This is what's known as a mono substituted double bond. Here there's 2 groups coming off, 2 carbon groups coming off the double bond, and 2 hydrogens. We aren't counting the hydrogens, we're counting the carbon groups. This is what's known as di-substituted double bond. Then here we've got 3 carbon groups. Now it doesn't matter if the carbon groups are 1 carbon long, 2 carbons long, 10 carbons long. What you're looking for is the number of different groups coming off the double bond, and here it's 3 groups, so that's tri-substituted, and this is 4. This is what's known as tetra-substituted. And the stability trend here is the more substituents you have on your alkene, the more stable it is. So therefore tetra-substituted alkenes are most stable, mono-substituted alkenes are least stable. So when we go back to here and we look at these double bonds, in each case we can put a circle or whatever you want around that double bond. And then you want to identify, well, how many different groups do I have coming off that of those carbons? Well, for this guy there's 1, there's 2, and there's 3 separate groups. It doesn't matter that they're all 1 carbon long. There's 3 groups going in 3 different directions. Here there is 1 and 2. These 2 carbons are together, but they're all 1 group. So therefore this is di-substituted, this is tri-substituted, and this guy, because it's got more substituents, will be the major product. This would be the minor. Alright, so you're always looking for the more stable alkene as the major product. Alright, so that's alkene, that's alcohol eliminations. Now, oxidations are the other sort of reaction. And to help answer this, I need to go through with you one concept, and that's the concept of primary, secondary, and tertiary alcohols. Alright? So let's take a look at this guy to explain it. This guy is CH3, CH2, CH2OH. Look at the carbon bearing the OH. And in a similar way as you did here, ask yourself how many carbon groups are coming off that CH2, or that carbon. In this case, it's 1. This is what's known as a primary alcohol. When you come down here, again, look at the carbon bearing the OH. And ask yourself, how many groups are coming off that? How many carbon groups? It's 2. That's secondary. Now this guy, so in cyclobutanol here, it's in a ring, but there's still 2 carbon groups coming off that OH. That's secondary as well. When we get up to here, we look at the carbon bearing the OH and ask ourselves how many groups are coming off there, and it's 1, it's 2, and it's 3. That's a tertiary alcohol. When we look at this guy, again, find the carbon bearing the OH and ask yourself, well, how many groups are coming off? Well, there's 1, there's 2, and there's 3. These are all tertiary. Now the reason why I'm saying that is because the type of oxidation reaction you see depends on the sort of alcohol you have, whether it's primary, secondary, or tertiary. So I'm going to show you what's happening here in oxidation. Alright, we're going to show an arrow. These are our reagents. For the purposes of what you guys need to know, we're simply going to show O inside some square brackets. This just means whatever reagents we're using for oxidation. So we're not talking about the specific reagents, we're just talking about the oxidation process. So anytime you see an oxidation reaction, you're going to see O to indicate oxidation. Alright? I'll do it for this one as well. So, when you have a primary alcohol, you're oxidizing, or whenever you're oxidizing at this carbon, the carbon bearing the OH. So you're oxidizing at this carbon, this carbon, this carbon. Now what do you guys understand by the term oxidation? Well, probably suggests you're adding oxygen, and that's exactly what you're doing. When you have a primary alcohol, you can oxidize that to first this functional group, where you go from a single carbon oxygen bond to a double carbon oxygen bond. Now this is a functional group known as an aldehyde. However, when you're doing this reaction, it's unlikely that you'll be able to stop at that first product. In fact, what you'll usually do is go all the way to this functional group, which is a carboxylic acid. So if I ask you a question of, if I have a primary alcohol, what's the functional group I'll probably get out? Unless the question mentions something about stopping halfway through, you're going all the way to a carboxylic acid. Alright? That's as far as you can go with oxidation of a primary alcohol. So for a secondary alcohol, you're going to do the same thing. The first thing we do is what we did here. We turn our OH into a C double bond O. So when we do that, what we get is this. This is called a ketone. Alright, you've seen this before. Now, when you take this guy and try and do what you did here, what happens if you put an OH on that same carbon as the carbonyl? Any issues with that anybody might notice? Well, of course there's an issue. You can't have 5 bonds to carbon. So what that means is, whenever you have a secondary alcohol, no matter its structure, its oxidation product is always going to be a ketone. Let's going to stop there. So for this guy, it's a secondary alcohol too. All we're going to do is turn the OH into a C double bond O, give us another ketone, and that's it. Now when we come to tertiary alcohols, if we try and apply the same logic, turn the OH into a C double bond O, turn the OH into a C double bond O, well, let's see what happens. In theory, this would be the product. If we did oxidation of tertiary alcohol, same thing for this one. Right, so if I do this here, I've got my methyl group there, and I've got this. Now, what's the issue with these two? Both of these have exactly the same problem, and that's here. You can't have 5 bonds to carbon. So what that means is, tertiary alcohols don't do anything as far as oxidation goes. There's always no reaction. So primary alcohols will give you an aldehyde all the way through a carboxylic acid. Secondary alcohols will always give you a ketone. Tertiary alcohols will always give you nothing. So it's important to be able to recognize the type of alcohol that you have. So in order to illustrate that, let's just run through 3 sample oxidation reactions. The first thing you got to do is recognize, do I have primary, secondary, or tertiary alcohol? This one, look at the carbon bearing the OH. There's 2 groups coming off it. That one's secondary. And from what we said in the video before, all you're doing in your oxidation is converting this OH to a C double bond O. So that's the product. It's a ketone. When we have this guy, that's Fe with the OH. There's 1 group coming off there. That's primary. This would give us an aldehyde initially, but if we go all the way to the end, we put the OH on there as well, because we can have 4 bonds for that carbon. We get a carboxylic acid again, because that's primary. This guy is secondary, alright? And we do exactly what we did up here. That's the carbon with the OH. That's how we tell it's secondary. There's 2 groups coming off it. And so that would be our product. If we took this guy that was secondary and stuck a methyl group coming off that same carbon, we get this, which would make it tertiary, and it wouldn't react. So we get no reaction. So that's the 2 different types of alcohol reactions that you need to know about: oxidation and elimination.